Question is, in terms of band theory, what is the difference between a conductor and an insulator? Answer is, we define a conductor that may conduct electricity through the movement of electrons or ions. The conductivity of metals depends upon the number of valence electrons available per atom. The atomic orbitals of metal atoms form molecular orbitals which are so close in energy to each other as to form a band. If this band is partially filled or it overlaps with a high energy unoccupied conduction band, then electrons can flow easily under an applied electric field and the metal shows conductivity. What is an insulator? So if the gap between the filled valence band and the next higher unoccupied band is large, then electrons cannot jump to it and such a substance behaves as an insulator. So question part 2 of this question is, in terms of band theory, what is the difference between a conductor and a semiconductor? So the definition remains the same as the first part of this question. Now we define what is a semiconductor. So the gap between the valence band and the conduction band is small. Therefore, some electrons may jump to the conduction band and show some conductivity. The electrical conductivity of semiconductors increases with rising in temperature since more electrons can jump to the conduction band because of the increase in the energy of the electrons. So here is a figure so that you can easily visualize and see what we have defined. So in semiconductor, there is very small energy gap between the empty band and the filled band, and for the insulator, you can see this is a very large gap between the empty band and the filled band.